Hello there. We are going to move into the next section, still chapter 1, section 5, and it's going to introduce an idea that we haven't talked about yet, which are angles. If you've already done the warm-up, as you should have, opening that file, these are the same 6 questions you had from that doc. These are all little degree symbols, okay? Should not be an unfamiliar label for you guys, but all of these degree symbols are just mentioning and stating that this is an angle that it's given. So this is an angle that is X degrees. This is an angle that would be 40 degrees. This is an angle that is 110. The solving process, however, should be the same. So for this first one, you would still minus 40 over, and you would get X equals 70. Same thing here. You would add 44 over and get R equals 179. You would add 19 over and get N is 144, okay, and so on. These last couple have a 2 in front of the variable, so you'll have to divide, right? You would minus 10 over, and then you would divide by 2 and get 65. But the solving process does not change just because they throw this little symbol in there. It's just showing that it's an angle. Okay, so this is the question, how do we measure and how do we classify an angle? This is a picture of a protractor. I'm going to wait and come back to this in a minute, but I would like to point out first, you see how there's 2 sets of numbers on a protractor? And you may have gotten some practice already in a previous math class with protractors, and typically I would pass out protractors and we would actually use them also, like, actual protractors in our hand. But with the state that we're in, I will not be passing those out, and we'll be doing this like digital way. But it's the same idea. There's 2 rows of numbers. If your angle is pointing this direction, like out here by A, you would start at 0 and go up in this direction. So whatever angle you were trying to number would be using the bottom row. If your angle was pointing out over here, you would want to be going from 0 this direction. So you would be using the top numbers. Okay, so you got to pay attention on what side the angle is starting from, and we'll do some practice with that here in a minute when we get to another slide. Okay, so these are all the things we're going to talk about today, and feel free to pause to write stuff down at any point. All right, 1.5, angles and their measures. So this first slide here is talking about that protractor postulate, and we will get some practice with that protractor in a second, but here's an example. All right, this is the vertex of the angle, and then it's going out over B in this direction, and it's going out over A in this direction. Those are both rays. So an angle is made up of 2 rays, and where those rays come together in this point O, that's called your vertex. And those will just be some important pieces that we'll be talking about here when we name them and use them. Okay, so the first thing is, how do we name an angle? Just like we talked about naming planes, naming segments. Let me go through this process with you. All right, when you are naming angles, you have a couple options, and one of them will be the one that I, encourage you to use, but obviously you don't have to listen to my recommendation. You can first name it using 3 letters. Okay, and I'll just hypothetically make up one. So this is how you name an angle. You use this little angle symbol. Kind of looks like a less than sign, but it's not like opened, it's flat. And because it looks so much like a less than sign, I put a little arc through it just so I can tell the difference. Just like my Z's, if you've noticed. When I write a Z, sometimes it looks like a 2, so I put a line through it. That's a pretty common math person thing. So I may not be the first teacher you've seen do that, but so that's what I do for this too. I throw that little arc through it just so I can tell that it's an angle and not a less than sign. And then if you're going to use 3 letters, and we'll do these examples up here in a minute. When you use these 3 letters, the only thing that matters is the middle letter. This middle letter has to be the vertex. So it has to be the middle letter, the vertex, the vertex, the vertex. Okay, so that's the most important. The other two, you could switch around. I could put C first and A last, right? That doesn't matter. But the vertex has to be in the middle. Oopsies. Okay, your other option is if you just use one letter. And this is not one I recommend because it's not always right. So this is the best way. If you want to be sure that you're always naming an angle correctly, that's the one you want to use. But you could just use one letter. But when you use one letter, the letter matters. You have to use that vertex again. So if I wanted to use one letter, it would just be Q. Just one letter, it would have to be Y. Just one letter, it would have to be E. And we're going to do these examples up here, but I'm just using these pictures to kind of show you along the way. And then the other option, you can use the number that they assign it. And they don't always do that. So that's why you can use it when it's offered, but then, you can't use it when it's not offered. Okay, so that's move these down. So yeah, that's just a little bit about naming. So now we're going to apply those up here on these examples. All right, so number one, they want you to name each of these three ways. So the first one, I could name angle Q because that's the vertex, just one letter, that works. I could also name this angle PQR. And notice when I use three letters, that middle letter is still my Q. And then as I said down here, I can flip-flop the P and the R. So I could also name this angle RQP, right? Q still in the middle. So those would be the only three names you could give for this. All right, number two, being they did give me a number in this corner, I could just name this angle 1. So it is a nice option if they give it to you. I could also name this angle Y because Y is my vertex. So if I'm going to use one letter, it has to be Y. I could also use three letters, but when I use three letters, my middle letter has to be Y, and the other two are just the other two in any order. So Z, Y, X, or I could do X, Y, Z. Okay, all four of those are correct. I know it only says to name three of them, but I figured I'd throw all four of them at you. But those all work. Okay, pause the video for a second and try number 3 on your own. Okay, you should have gotten angle 2. That would work. Angle E, because E is the vertex, so just one single letter E would work. You could also name it FED. Again, E has to be in the middle. Or angle DEF, E being in the middle again. So you only had to do 3 of them, but they're all 4 options. Hopefully you got 3 of those 4. All right, types of angles. I know this is not the first time you looked at this. Maybe even elementary school would be the first time you would see this, but go ahead and pause if you would like, if it's a little too fast for you on the video, but get all these definitions written down. Acute angle is an angle from 0 to 90. A right angle is an angle that's exactly 90, not 89.6, not 90.2, but exactly 90. And then this notation is very important because they don't always tell you 90, but they use this little symbol. This little box in the corner means 90 degrees. Obtuse angles, which measure from 90 to 180. And straight angles, which are really just straight lines. But they measure, they measure 180 degrees. And that's really a really important one that we will end up using, even though it doesn't seem like an angle because it's just a line. It has a measurement of 180 degrees, so that's why we call it an angle. All right, so back to the protractor that I kind of pointed out quickly earlier. Let's use these angles and practice measuring with a protractor. So the first angle here is GHK. So that's starting out here at G, going into the vertex H, and then coming back up here through K. All right, so this is the angle we're talking about, and I'll highlight it. Not too bad. Okay, so if my green line is coming out here, I'm starting at 0, so I'm going to be using the top numbers. All right, I'm totally ignoring the bottom numbers for this angle. Top numbers, all the way over to G. It's right in between 120 and 130. So this would be 125 degrees. And then they want you to classify that angle. And because it's larger than 90, but less than 180, and that was a definition you wrote down a second ago, that's an obtuse angle. Okay, let's erase these markings and re-highlight in a different color. Now we're on JHL. So now this one is starting over here. JH, and then we're going up to L. Kind of missed that, but you know, you get the idea. So now we're looking at this purple one. If I'm starting over here, now I'm using the bottom numbers. Okay, I would be using the bottom, ignore the top. Now this is the one that it doesn't matter what direction you come from because it happens to fall right in the middle. So that would be 90. And a 90-degree angle, exactly 90-degree angle, is a right angle. So that would be classified right. And then LHK, L is up here, H is the vertex, and then we're coming out over K. That's this red angle. Now this one's a little bit weird. If we had a protractor, you know, in our hand, I would actually take this protractor and turn it, you know, so that we could, I want to say they give you that option, but yeah, so you could turn it so that, you know, this angle was exactly down here, and then you could read the numbers. All right, that is what we would do if we actually had a protractor. We would pick up our protractor and turn it so that it was on the angle, so that an angle was pointing down here at 0. But let's just say, you know, we don't have this whole twisting and turning option, and we just have to kind of measure with what we're given here. Then this is going to be from 90 over to 125, right? I'm following the top numbers. Or you could follow the bottom numbers. That would go from 55 up to 90. Either way, the difference of those two measurements will be the same. All right, so you would end up getting 35 degrees. And that is less than 90, so we would call that acute. Okay, so we'll get some more practice digitally using a protractor. All right, you could take a second, pause the video, give these a try. Same picture, same letters, I think. It's just, you know, different angle names over here. All right, angle addition postulate. Don't write everything down, but you need to know this picture. I think the diagram is very helpful. And then this equation down here with all these colored angles. Everything's color coded in the picture. You may not have that option if you only have a pencil in your hand right now. But this is nice to see, like blue is the whole thing. Red is this top chunk. And green is this bottom chunk. So it's saying the same thing it did for segment addition postulate. If you have one piece of the whole and you add it to the other part of that whole, those two pieces together make up the whole thing. So that's all this is saying. You can feel free to write the words definition also. I just usually find that diagrams and equations that go with the diagram are most helpful. All right, so here's an example. They tell me over here that the measure of angle LKN is 145. So LKN, that's the whole thing, right? The whole angle is 145 degrees. I'm going to take the two pieces inside that hole and add them together and set them equal to the whole thing, which was 145. So this is the equation you get. And now you're just going to solve it using algebra. 2x plus 4x is 6x. 10 minus 3 is 7. Minus 7 over. And divide both sides by 6. And x would be 23. But same thing on the quiz and the review stuff that we've done in the last week. They don't ask you to find x. They're asking you to find the measure of one of those angles. So you're going to take what you get here and plug it back in for x. So the measure of LKM, which is where this arrow's pointing, right, and this little wedge down here, you would get 2 times 23, which is 46, plus 10. So this angle would be 56. And then you do the same thing for the other one. Plug 23 in here, and you would get 89. And 56 plus 89 is 145, so you can kind of check your answer to make sure you get the right x value. Okay, this is the same idea. This time they don't say that the measure of something is a specific number like 145, but it tells you it's a straight angle, and we know straight angles are 180. So this equation would say 10x minus 5, and I would add that to the other angle, which is 4x plus 3, and that has to equal the whole thing, which is 180. Not sure where that little black thing came from, so I erased it. All right, and then for this example, then you could finish solving that out. And then for this example, again, it doesn't tell you the angle is, a specific number. It just says it's a right angle. And we know right angles are 90. And notice they put the little 90 symbol down here in the corner anyway. So they really didn't even have to tell us this in the problem because they already labeled it for us in the picture. But being we're just learning, they're probably reinforcing that right angles have these little corner marks. So you would say 2x plus 2 added with x plus 1 would have to equal the whole angle of 90. And then again, you're doing some basic combining like terms and solving. Okay, go ahead and pause these videos, give those a try, see if you can get a solution, and then check it, plug it back in, and make sure those add up to 180 or actually add up to 90. All right, last thing for this section are angle bisectors. So segment bisectors were talked about, right, when we did segments. So if we have a segment, oops, as I say that, I draw a line with arrows. If I have a segment and I have this point in the middle that we call M, if the left side and the right side are the same size, then M is a midpoint, right? It's a bisector of the segment. Cuts into two equal pieces. That's exactly what angle bisectors are. Angle bisector is a ray that divides an angle into two equal parts or two congruent angles. Okay, so here's a picture, and what we can mark here is that this top and this bottom are the same. So just like I did up here for segments, I put those little tick marks, those little dashes showing that the left and the right are equal. You can do the same thing for angles, but they're they're done by using these little arc symbols. So if you ever see arcs in the corners, you know those two are equal to each other. Okay, so here's an example. I know that QS bisects PQR. So PQR is the biggest angle here. That means that this thing in the middle, QS, is cutting it in half. So this and this are the same size. Well, they also tell me that the measure of PQS, which is this top left, the top part of this angle is 24 degrees. They would like me to find PQR, which is the whole thing. Well, I knew this part's 24, and because they told me it was a bisector, I know that it's two equal pieces, so that part also has to be 24. And then if I use the angle addition postulate, if I add those 24s together, it gives me the whole angle. So this has to equal 48. All right, so look for keywords. Bisect means two equal parts. So that's when you know that some of your numbers are going to be the same. If they don't say anything about bisectors, then you're going to have stuff like this where you know that you can add two parts together and it'll equal the whole. Okay, so those are two different ideas, very similar in nature though what they were for segments, but now we're just doing it in the angle side of things. Okay, go back and re-listen, rewind, pause, retry some of these problems. You now have an assignment on big ideas, should be opened, so go ahead and check that out, and I will catch up with you next class.